Right, this is June 2004 question 4. In this part of the question you will answer in continuous prose. You will be assessed on the quality of your written communication. Part A, a person is pushing a car at a constant speed along a level road. He has to exert a large constant force. State Newton's second law of motion. Discuss the situation with reference to the law. So you have to state Newton's second law. So that's going to be a mark. There's 4 marks altogether. The constant speed bit, you're going to have to discuss that. There's going to be at least 1 mark for that and possibly 2. And something about the force for a mark. So there's 3 out of 4 marks just from reading the question. So the first thing we're going to do, not going to do this in continuous prose, but you will. So Newton's first law, so you're going to state F equals ma, resultant force equals mass times acceleration, and that will get you a mark. Second thing we're going to discuss is the constant speed. So when the car is moving at a constant speed, that means forces acting on it are balanced. And therefore, any resultant force is equal to 0. So that will get you a mark. So then, obviously, if the resultant force is equal to 0, A is equal to 0 too. There's no acceleration. So therefore, this means there must be a force balancing out that large constant force which is moving forward. So that means there must be a frictional force which equals the large constant force. And that would be a pushing force or a motor force or a force from the engine. I'll just call it a pushing force. And that's enough there to get you your 4 marks. And of course your quality of written communication will get you a 5th. That wasn't too bad. Look at the question, underline the important bits, and then try and work out what you need to say about that. Part B, a person of mass 70 kilograms stands on bathroom scales in a lift at the top of a building. The lift descends. After a brief initial acceleration, it moves with a constant speed of 4. Determine the reading on the scales while the lift is moving at a constant speed. If we just draw the lift, draw the person in the lift, and draw the scales are standing on. So the lift is going downwards, but it's moving at a constant speed. Now, if you look at that, that means that there's a force downwards on the scales due to the weight of the man. And then there's another force, and I'll draw it in a different colour so you can see it. And that's the force of the scales upwards on the man. And those 2 forces, because this is moving at a constant speed, those 2 forces must be equal to each other. So the reaction force is the weight or the reading on the scales, and that's equal to the weight of the man. And that's just going to be equal to m times 9.81, or 70 times 9.81. And that is going to give you an answer of 680. 6.7 newtons, or they've written all their questions, the numbers in their questions, to 3 decimal places, so, or 3 significant figures, I should say. So that should be 687 newtons. Now the lift continues to descend, but now accelerates. So I'm going to draw the lift again, and the man in the lift, and the scales. And therefore this time we've got an acceleration, and it's 0.5 metre per second squared. So therefore there's a downward force due to the weight of the man again, and there's an upward reaction force due to the scales. But this time, because it's accelerating downwards, the total resultant force is also downwards, and that means that W must be greater than R, because it's accelerating downwards. So the resultant force is W minus R this time, and that's equal to mass times acceleration from Newton's second law. So W again is that value from up above here, mg, 686.7. We're still looking for R, the reaction force due to the scales upwards in the man. The man's mass is 70 kilograms and his acceleration is 0.5. That gives you 35. So therefore 686.7 minus r is 35. And when you rearrange that, r comes out to be 651.7 or 652 to three significant figures.